I thought this was just a cute, funny way to start off normal distributions. So what is a normal distribution versus a paranormal distribution? No, not really, but what are normal distributions? First, let's quantify outliers. So outliers, remember, our distributions are described by their SOCs. In statistics, when we consider differences between distributions, we look at all of these characteristics: the shape, outliers, center, and spread. Let's look at the O in SOCs, which would be outliers. So outliers are defined numerically depending on whether you're using the mean and its measure of spread, the MAD or the standard deviation, or if you're using the median and the IQR. So if you're using the mean and the standard deviation or the MAD, an outlier is considered outside of two standard deviations, above or below the mean. So to determine the value, you take the mean, subtract two standard deviations for the lower value, and you take the mean and you add two standard deviations for the upper value. Anything beyond those boundaries is considered an outlier. On the other hand, if you're using the mean, you would be using the IQR as your measure of spread. And an outlier is considered beyond 1.5 times the interquartile range. So to determine the value, you multiply the IQR and 1.5, that calculates 1.5 times the IQR. Then you subtract that value from Q1, which is the lower quartile, and add that value to Q3, which is the upper quartile. So outside of those ranges is considered an outlier. Now let's talk about those distributions. Remember, we have uniform distributions and bell-shaped distributions, which are considered symmetric. And then we also have asymmetric distributions, which are right-skewed or left-skewed. And you can discount the skewness depending if you can say that there are outliers. So normal distributions. Here's some important characteristics of normal distributions. Normal distributions are symmetric about the mean with a single peak. The mean and the median and the mode are all the same in a normal distribution. Because the distribution is symmetric, 50% of the data lies below the mean and 50% of the data lies above the mean, for a total of 100% under the entire curve. Data values farther from the mean become increasingly rare. That's why we consider them outliers. The graph of the normal distribution is bell-shaped with tapering tails that approach but never actually touch the horizontal axis. And almost all of the data under a normal distribution curve is within 3 standard deviations of the mean. Which brings us to the empirical rule. Within 1 standard deviation, 68% of our data lies, so that's why we report it typically. Within 2 standard deviations, we have 95% of our data. That's another reason why outside 2 standard deviations would be considered an outlier. Then, within 3 standard deviations, we have 99.7% of our data. So outside of those 3 standard deviations, here and here, we have very few data values, so they're increasingly rare. Let's talk briefly about Z-scores. If we want to compare two different things, like houses in Phoenix compared to houses in San Diego, or if we want to compare ACT and SAT scores, how can we do this? Well, we use something called a Z-score. A Z-score gives us a standardized value in relation to the mean. It literally says take the data point, subtract the mean, and divide it by the standard deviation. So it's standardizing this to say that now the Z-score is 0, that would be your mean. And then 1 standard deviation above the mean would have a Z-score of 1, 2 standard deviations above the mean would have a Z-score of 2, 3 standard deviations above the mean would have a Z-score of 3, and the same on the other half. So a Z-score of -1 would mean you're 1 standard deviation below the mean. A Z-score of -2 means you're 2 standard deviations below the mean, and a Z-score of -3 is 3 standard deviations below the mean. So what does a score of 1.47 mean? Well, think about it. A z-score of 1.47 would be here. So it would still fall within the typical score range because it's within 2 standard deviations, and it is 1.47 standard deviations above or to the right of the mean. We can connect this to percentiles in the future. Look at the standards that this connects to in 6th grade. They need to be able to measure variability, interquartile range, and mean absolute deviation. And they relate the choice of measures of center and variability to the shape of the data distribution in context to which the data was gathered. I hope this helped you understand the normal distribution and some z-scores.